Hello to anyone watching this video. This video is an introduction onto particle accelerators. In this video, I intend to talk about just what is a particle accelerator, the different types of particle accelerators out there, whether it be a linear or a circular accelerator. I'll discuss what the difference is between those and what the use case is for those two accelerators. I will also get into the physics behind particle accelerators and just how I guess the development on a physics level particle accelerator is created. I will also go over the practical uses of particle accelerators and how they kind of fit into today's society and what they are used for. So super exciting topic. Particle accelerators have a lot more different use cases than you might imagine. It's not just for colliding two particles. There are different use cases for them that come in handy. So in this section, you see a model of a particle accelerator. You see a proton on your left, and that proton is the particle that we intend on accelerating through this accelerator. To do this, what you do is you send it through a potential difference over and over and over again. The potential difference can be the gaps in between the inner vacuum tubes. Each difference essentially gives it an additional force or exerts an additional force to speed up the particle, and then when it's in the tube, the particle's speed is constant. So you run it through a constant speed, increase the speed, and then run it through that constant speed, or run it through with that constant speed, then do that over and over, increase it again, run it at a constant, increase it, run it at a constant, until you have speeds pretty comparable to the speed of light. So although particle accelerators are different in how they're constructed and how they're designed, there are some basic principles that all particle accelerators kind of meet. The first one would be kind of the control of the particle accelerator in order to run it through your particle accelerator, and this can be done with an ion source or some sort of emission of a charged particle into the particle accelerator. We saw this in the photoelectric effect in class as we removed electrons from metal. Similar principle holds with the particle accelerator. The second is you want to increase its energy. This is always done by running it through a potential difference. Each time it undergoes a potential difference, it gets a slight increase in energy and an additional jolt of speed. The third kind of principle is you want to be able to control the particle or not lose your particles during this process. This is done as with magnetic fields, as they can be thought of as a force that kind of holds the particle in place in the middle of your vacuum tubes. And then the fourth aspect would be the delivery of the charged particle. And this depends on what you intend on doing with it, whether it is an injection into a target or you want to collide the particles and create new elements or new basic particles. So this is a model of a particle accelerator, and as you can see, C1, C2, C3, C4 are those tubes, and the gaps in between the tube is where the increase in energy and speed happens. The tubes are just the constant, they hold the speed constant in place, and then as you can see in between C2 and C3, it's going to get an additional increase in speed. So about the different types of particle accelerators, this is a circular accelerator. The last image was a linear accelerator. Circular accelerators use magnetic fields to drive the component the charged particle in a circular aspect. They are very good at, because they work with circular acceleration, they are very good at getting top end speed of a particle more comparable to the speed of light, or c. Whereas linear accelerators are good at getting a good constant speed, still fast, but not relativistic in regards of ratio of the speed of light. So this is kind of a particle that goes through an example of a particle that goes through a linear accelerator, and then it goes through a circular accelerator for that good top end speed. So the main difference between circular and linear accelerators is circular accelerators use magnetic fields to kind of drive the charged particle. So the use case of particle accelerators, there is quite a few. One that I thought was interesting was the delivery system. Talked about whether it be collision or injection. In this case, with the healthcare system, where you inject electrons into a target. So anytime you go and get an X-ray, you're essentially dealing with a particle accelerator, a machine that speeds up and creates high energy electrons and then emits them onto a target. In the case of an X-ray, it would be the hand or the broken hand or the broken leg or whatever it may be. You send those electrons to the intended target. Then they scatter, and there's a detection device on the X-ray machine that captures the change in angle, and that's how you're able to get an X-ray image. Another interesting thing about particle accelerators or in the healthcare system would be photon therapy. It is a new style of healthcare. It's where you take a particle accelerator. In the particle would be photons. You speed them up, create them high energies, and then you send them. You inject them at a target. In this case, it would be a tumor or cancer or something along those lines. I'm not a doctor, but that is the kind of the use case of it, and somehow those photons or the condensed beam of photons are able to break up the tumor or eliminate the cancer cells. So pretty cool particle accelerators. I mean, you can also collide them. Once you collide them, as they meet, they create new particles as well. So that's an introduction on particle accelerators and why they are so cool.